Good morning, everybody. My name is Stephan Gumpert. I'm a technical specialist at Autodesk, covering all things structures, fabrication, and cloud. Today, what we're going to do is we're going to cover a webinar or do a webinar where we're going to talk about the differences between BIM versus just plain old CAD, or the whole concept of why would you move from 2D to 3D. So first of all, from an Autodesk perspective, our vision is to help people imagine, design, and create a better world. This is our vision statement, and this is important. Okay, Autodesk is dedicated to helping customers, not just in one industry alone, but in quite a few industries. So, for example, not just the AEC, the architecture, engineering, construction space, which is what we're going to look at today, but we're also looking at things like manufacturing, construction, and of course the movie and TV industry, which is quite dominant as well. So on today's session, we're going to have a look at BIM. Obviously, we're going to have to go through a bit of an agenda here. So we're looking at, first of all, the introduction, have a look at the history of design, what is actually BIM, how is BIM different to CAD, and what's the benefits of going down that BIM workflow as opposed to sticking to that 2D. Then we'll have a look a little bit at Revit, what it can do, how the documentation and visualization components can be utilized as part of Revit, and then see the difference overall. So first we want to do is we want to have a look at the history of design and documentation. So if we go back to the very, very beginning, if you go back far enough, and I just teetered on the edge of this beginning, if you like. But look, documentation at the beginning was predominantly done with pen and paper, set squares, T-squares, on a drawing board. There's probably one thing you'll notice on this picture that's quite different if you've grown up in probably, say, the last 15 years in a design office. And that is a guy in the bottom left-hand corner there smoking a pipe. But it then evolved to what we would refer to as the era of documentation. So CAD came on board, in particular AutoCAD. It was very focused around the 2D side of things. Obviously, AutoCAD can do 3D as well. But, initially it was all around what we would refer to as the era of documentation. That then quickly followed on to the next cycle. So instead of drawing lines, circles, and arcs, we went to drawing things in 3D. So modeling things in large files, in 3D solids, and in some cases with intelligent software as well, which is obviously quite different from a 2D space, but still, not quite that BIM space. There's still quite a lot to be done, or differs between what we would do today. So if we have a look at today and look at the concept of BIM, so BIM actually stands for Building Information Modeling, right? And the process of using BIM actually enhances your designs, or enhances the way you conduct or operate yourself during the creation of the design, to give you the ability to put more thought into the actual design as opposed to worrying about, did I leave those lines on the correct layer? Did I give enough information in that picture for people to understand? Because it's not just about 2D, it's also about the 3D component. If we start with, probably the biggest important thing is that BIM is not something you can buy. It is a process. It is a methodology. It is not, a purchasable thing, right? If we say, for example, during the process, you're actually modeling intelligent objects which are customizable. So, for example, I want to model a pipe, and your pipe is of a certain designation, and that designation size pipe has a particular wall thickness, it has a coating, it has a volume. There could be all sorts of data attached to it, and we'll talk a little bit about that moving forward. A lot of things in the 2D space, not in all cases, but in some cases, was what I would call using draftee's license, or was fudged. So, for example, it looks approximately how it's going to be on site at the end, but not exactly. And with BIM, the difference is that you're placing things accurately in more of an intelligent space, giving you a 100% real representation of what it actually will look like, or close to 100%. You can build, in some cases, we actually build relationships between objects. So, for example, locating columns on a grid line, so that if the grid line moves, maybe we get the column to move, or relationships between, say, a steel beam and a steel column, for example, right? So there's all these things to consider, because at the end of the day, all this makes a difference, right? The objects themselves have data attached to them, right? We talked a little bit about that during the intelligent modeling component. The important part to think about here is that the data is extendable. So, whether you want to have one particular standard versus another, the amount of data you want to capture, or the level of detail of information that you want to capture, is totally up to you, and you're able to capture that however you like, and this is done in that BIM-based application. The object representation is also customizable. So when you define these intelligent objects with your data, we can determine what the appearance of those objects are in a 2D space, in a 3D space, at particular levels of detail. So whether they're represented as a line in a widget, for example, for a steel component, or whether it shows the full hidden detail of an object, all this can be defined as part of those particular objects. And of course, the final component is that all this data is then available at your fingertips to use in either further downstream processes, or to help analyze the current design to make sure that you're in that right space. So the big question is why? What are the benefits, right? So if we look at BIM itself, right, it's modeling and designing everything in that one space. So when you want to, put in doing the modeling in a multidiscipline phase, whether it's concrete, steel, being able to take that data further to the fabrication space, making sure that the documentation is an exact representation of what's in the actual model. As I said in the beginning, in the 2D space, and I'm sure we've all been there before, sometimes we'll use a bit of quote-unquote draftee's license to fudge things and make them look, say, easier to read. But in reality, that actually creates a misconception, because that's not actually what it looks like. So if the detail needs more blown up scale views of something, we should do that, and it should show exactly what it is. And when we use that BIM approach to things, we do end up displaying the pictures, or displaying the 2D documentation to match exactly what the objects represent. The difference from BIM to CAD could also be said that you gain more productivity because you can collaborate on a multidiscipline perspective, and because you have all that data at your fingertips, you're able to get insights into your model or your design that previously were not so easily to get, right? So, if we look at the way projects are changing, the fact that our cities are going through a massive expansion due to urbanization, more and more people are moving to cities just because there's more opportunities in cities as opposed to living in remote rural destinations. And governments in many regions are starting to mandate BIM as a deliverable. Being able to work with all those people in one particular office, as we saw in that very first slide, that's becoming far and far less less possibility than ever before. So having distributed teams in multiple locations or outsourcing components of work, BIM gives us the ability to do this, in particular by using certain products and opportunities when you incorporate cloud. So what we're going to talk about today is we're going to talk about Revit, because Revit is a BIM-based workflow. I mean, it supports multidiscipline design. So, for example, we've got architecture, we've got structure, both steel and concrete. You've got the MEP components, so the mechanical, the electrical, the plumbing, can all be done in one space, right? So, being able to make that design and the changes is both important. So obviously being able to do the initial design is important, but being able to make changes to that design and have it reflect intelligently from one drawing to the next, because our models are an exact representation of what's in our model. This is important, right? So when I change my ducting from, a 600 by 600 piece of duct to a 600 by 900, the intelligence that comes with it is obviously it's parametric in that, the amount of volume that's inside that ducting changes, which means everything that is generated from that model, i.e. the plans, sections, elevations, schedules, automatically update. Obviously, from the analysis perspective, things update at the same time. And of course, if we're using the cloud for collaboration and coordination perspective, having things update is important as well. So essentially, the big takeaway here from Revit is that we're working in a multidiscipline environment. So whether it's structure, whether it's architecture, whether it's plumbing, electrical, or mechanical, these things can all be considered in the one environment. And as I said, when we're drawing walls, we're drawing walls. When we're drawing windows, they're windows. And it's a multi-disciplined approach to design. Another way to have a look at this is on this graphic here. And this is not an unrealistic image. This is something that, you can look at and you can sort of take into consideration the amount of disciplines that would go into a structure or into a building like this. As I said, if you were to do a steel structure, we can do steel, we can do concrete. If we start looking at the modeling of the MEP components, here you can see the difference in the display of the 3D versus the 2D, right? But essentially, it's still all the same objects in the same space. And of course, another aspect to have a look at, and because I come from that structural space, the precast elements, whether they're precast hollow core slabs, whether they are solid walls, cast off-site in beds and then shipped and installed on site, it really doesn't matter. There's a whole range of options available to you. So let's have a look at some examples of this stuff, right? So here you can see an image supplied by HOK, some architecture. This is just one example where you're able to utilize Revit for that design space. Whether it's the structural component, whether it's the, whether you're simulating the heating or the energy cooling side of things, it really doesn't matter. Revit can do it for you. Or whether you're working in just a plain old house design, right? So you're producing nice visual graphics to give you the full experience of what that design looks like. Or at the same time, being able to produce that 2D documentation for the builder or, for your estimators to be able to quantify what's actually in there for the construction of that house. Whereas I said, we're in a multidiscipline space. So, whether I'm drawing the mechanical, the plumbing, whether it's the ventilation outlets, it doesn't matter. It's that one space where we can coordinate everything together and visualize everything in a 2D, 3D sense irrespective, you can do all that. If we were to look in this space, you can see we've got precast slabs, or we got potentially cast in situ type documentation. Again, I'm just visualizing and consuming this data however I want. So for example, on the picture on the right hand side here, I've set up some rules inside my application to represent the different diameter of bars with different colors. So visually, without me having to look at some 2D annotation, which you would do in the 2D sense, I can visually identify, because I know that yellow is an N20 and red or pink is an N32. I can visually consume that information in a much different way, and I can visually look at that design and say, you know what, we might have some problems tying off the bars in that case. Maybe we should do ABC to change what we want to do. But of course, we can still see the 2D documentation, and essentially because our model and our 2D documentation is still all in the same space or the same environment, you can see here when I select on this pad footing, it tells me that it's 2 meters from one grid line and 4 meters from another. And clicking on those dimensions will then allow me to move those objects, because this object has that relationship between those two grid lines for me to be able to position that element. So instead of saying, offset that grid line 4 meters to the left, then offset it by the width of the pad footing, maybe draw me in a rectangle, or offset from the other grid line back 2 meters to find the center in the other direction. We're actually working with intelligent objects with relationships to each other. Again, like I said, it's not just a 2D or 3D application. You've also got the ability to then quantify, or in this particular case, produce a bar bending schedule of all those bars that are located in my model, which again takes you to that next level of detail for that fabrication space. So in this case, I'm actually producing a bar bending schedule for the rebar, which obviously takes my design to a whole nother level. We don't need to go to that level, but you have the possibility of going down that direction. And sometimes this can give you better insight into your design, because what you do conceptually in 2D might physically not actually work in 3D. If we look at the structural component of it, and this is probably my bread and butter more than anything else, than other things that I talk about. But if you look at the fact that we can place steel connections, knowing maybe the exact lengths of bolts, where plates are going to be from a connection perspective, rather than just placing a generic 2D block like we could do in the 2D space, we can actually annotate a physical view taken from the model with a real as it looks connection, potentially even produce a schedule of bolts that are required, dimension the bolt setouts, and so on and so forth. So you can see the level of detail that you can actually produce inside of that Revit space. So far, we've talked a lot about the design component or the documentation side of things. But I mean, wanting to do visualizations like some, shadow diagrams or renders to sort of see what it would look like when the sun is at, say, 2 o'clock in the afternoon. Being able to do clipped views inside of Revit to render out those scenarios out to people for visualization or consumption of your model, it's obviously going to help convey the intent of your design. And this can be done quite easily with Revit as well. So there's a lot you can do in that one space. Instead of talking to people about a bunch of PDFs or 2D documentations, you can consume a nice, rich 3D environment, which is not all that hard to produce. And that misnomer that 3D takes longer than 2D, not actually true. We talked briefly about collaboration. So on large projects, it's probably beneficial to have everybody working in one particular file or one particular Revit model. And this is possible. We don't have to work this way. We can work with multiple Revit models and reference them into each other just like we do in AutoCAD. But from a collaboration space, what we can do is we can have a look at Revit and that cloud work sharing capability that BIM 360 Design brings to that Revit space, bringing all the teams into that one environment. So BIM 360 Design is a cloud work sharing package which allows Revit to sync its model back to the cloud. And in this particular case, we're talking about BIM 360 Docs, which is that data storage component of the BIM 360 platform, allowing multiple teams to work share in that one particular file, giving you that full design collaboration ability across that whole design space. So a bit of a visual graphic here to show you the concept of when you introduce the cloud, or when you do introduce the cloud, you end up with what we would refer to as connected BIM. But you can see how bringing everything into that cloud space could potentially lead for optimization, maybe AR, VR, maybe utilizing the cloud space for simulation. I mean, there's a whole range of different things apart from just bringing multiple teams together in one environment. So, for example, if you had one team working in Perth, another team working in Brisbane, maybe one in Sydney, using the cloud space or BIM 360 Design to connect these two together is one option. So let's see this in practice and then have a look at some of those components. So let's have a look at Revit itself. So I've just fired up Revit here and I'm going to create a new model. So just like in AutoCAD where we can pick a template, well, we can configure a template as well inside of Revit, right? Obviously, if I've got a project that I want to start up, you can see it here in this interface, or we can come and choose a standard template. So let's say, for example, I use a structural template and I fire up a new project. So the first thing we want to understand is that Revit is a self-contained file. There is no separate drawings to 3D. It is all the same thing. So essentially you'll see on my project browser on the right, and this can be docked and stored wherever you like, you can see a bunch of different things. So first of all, you've got your views, your legends, your schedules, your sheets, your families, and families is something that is very important because this is the basis of everything in Revit. But essentially, this is my model and my drawings, right? At the moment, you can see I have no sheets. I've just got a bunch of levels and I've got a bunch of elevations as well as one 3D view. So you can see if I switch to a 3D view, which creates a new view for me, I can see two levels here, right? Or if I go back to level 2, you can see I have my north elevation, which is my north elevation here. And when I click on my north elevation and click on my view, you can sort of see that this is the direction that my view is going to be traveling in, right? So if I click my north elevation, you'll see my levels 1 and 2, which is my levels 1 and 2 here. Or if I go to my south elevations, I see the same thing. Now, if, for example, at the moment you can see that if I click on level 1 is locked. And if I go to level 2, it's also locked, right? Now, what I can do is I can say, for example, move that to 5 meters because that level 2 is related back to level 1 by this dimension. This is that relationship that we were talking about. Now, I've just changed that in my south elevation. If I go and look in my north elevation, here's the first difference you'll see between AutoCAD and using Revit, in that when I adjust something in one view, everything else adjusts in the other. So essentially these elevations is really just and what looks like a 2D view is really actually a snippet or a view of the 3D model at this particular location. So let's go in level 2 and show you how we might construct some grids. So myself being a structural draftsman, I'm going to come in here and look at placing some grids, and you can see I'll place my first grid in this location. Now, by default, when I go to create my next grid, you can see automatically the system comes and sort of gives me a suggestive difference and an intersection, a little bit like the object tracking, so that I know exactly where I'm going to place my grid. And if I pick here, I know it's exactly 10 meters, I know it's 90 degrees, and when I go near that other endpoint, it's now linked together. And you can see the elements are all controlled together. Now, obviously, the other thing you'll notice is it's come in at grid 2. Now, I may choose to come in and create a few more grids this way, or I can choose this and copy them along, right? So obviously I can copy it along 7 meters. Again, you'll notice it's changed here in from 3 to 4, which is something that you want to do. Now, if we go back to the north elevation and have a look, you'll notice that my grids themselves appear here as well. So let's just grab this node here and drag this out. Grab these grids, drag them down a little bit, maybe grab this, drag it out a little bit. So you can see no matter whether I'm in the south elevation or north elevation, I can see my levels and my grids. Or in level 2, I can see my grids. If I go to level 1, I can also see my grids. So you can sort of see how you're actually creating intelligent objects, and this grid is actually a plane. It's just the representation of that plane as a 2D line with a bit of data attached to it. And you can see here, when I click on it, you can see the name of that grid that appears here. Now, Revit's actually smart enough that if I was to now place a grid in this direction, right? Cancel that. You know, for example, I don't want a B5, I want a BA, right? So now if I come in and choose to copy that down, and let's go down, so just like AutoCAD, I can type in here, go 5 meters. You can see it's come down 5, and I've now got a grid B. And of course, we can do this all day long. And if I want to do multiple, well, I just check the option up here, come into here, choose 9 meters, then maybe 4 meters, and then 5, and then we hit cancel and cancel, and you'll notice that I have my grids. Now, just like when I switched to my north elevation, if I now switch to my east elevation, I would expect to see grid A on the right. So if I go to my east elevation, there it is, there's my east elevation. And again, I can drag my levels out and drag them out the other way. And if you go this way, you can drag out the grids. So just like creating grids, I can do the same thing with levels. So for example, I may want to copy that grid up, that level up. I can do exactly the same thing. But for intents purposes today, it's not important. So when modeling our components, whether it be structure, architecture, steel, MEP systems, so you can see HVAC, you can see plumbing and piping, electrical, and there's a whole range of different things here. Everything's related back to something called a family. Now, a good way to describe a family is like a dynamic block in AutoCAD on steroids. That's the way I like to describe it to people. Essentially, you've got this dynamic representation of this object. It has, as we said, information on how it should be displayed. We have metadata that's attached to these objects. And just to show you a little bit example of what I mean, if I was to come and place a steel beam, so these are predefined libraries or families that have already been loaded into my system, and you can see them here. There's a whole range of families in my model. Essentially, when I come to drawing this beam, right, I can hover around and you can see that, again, just like when we drew the grids, it's giving me some dynamic information on screen for placing this object. So let's say we want to place this beam on level 2 between these two grids. Cancel and cancel. Now, at the moment, you will see just a simple old line. Now, when I pick on this line, it is actually a 310 UB32. But at the moment, based on my level of detail, and you can see we've got 3 levels of detail in every view, right? At the moment, we are on what's referred to as coarse. Okay. If I switch to fine, you'll notice that the beam shows me the web, it shows me the outer edge, and this is important because this level of detail affects only this view. So if, for example, you want to take this view and it should be a 1:50 detail, we can change the scale. You can see the representation of all the objects in that view are going to be quite different. But you can see how quite quickly things change. If I draw another beam, let's say from here to here, you can see that they automatically connect to each other, creating that relationship between the two. So rather than overlap the two together, just like you would expect to see in AutoCAD, you can see they automatically connect to each other. Now at the moment, really all it's doing is putting an automatic cutback on there for me, but you can see there's a whole bunch of information attached to these objects. The length, the volume, the elevation that it's at, and in this particular case you can see it's on 2 different elevations, right? But the important part to remember here is that the objects that you're placing are intelligent, right? Again, if I go to level 1 and I want to place, let's say, an isolated footing, again, I've got 2 different types here. I can come and place this footing, so depending on where I want to place it, I can place it anywhere I like, or I can hit the space bar to rotate it, and you can see the footing is rotating. I can snap it to a grid, whatever I like, and again, when I place this view and this object and I go and look at it, it has information attached to it. So the footing, because it's different to a steel beam, it automatically has things like the cover on the top face, the bottom faces, and the other faces on that object for when we place rebar. So you can see it's quite different to how we see things. So you can see, if I switch back to my coarse view, in this particular case, the definition of this footing hasn't changed. But our beams that we had over here on level 2, if we switch between fine and coarse, you can see the display changes. Hopefully that makes a little bit of sense. If we have a quick look at the families themselves, if we look at this footing here, for example, if I needed a different size, obviously there's no settings here for the type of footing, right? But yet I can choose the different type from the drop-down list and just change it, and all its parameters and properties change. But what happens if I need a size that doesn't exist? Well, what I can do is I can come in here, I can duplicate the type, give it a name. Let's say we want a 500 and we want a 15 by, let's go 900 by 1500 by 500. I've now created a new type, but I need to then go and adjust the parameters accordingly. So I said I want to make it 900, and then I want to make it by 1500, and make it out by 500. Now, the rest of some of the parameters here, there could be calculated values on the back end that are calculated by these, and these are automatically done. And now when I pick OK, you can see I have a third entry to this value. Now, when we talk about the actual families themselves, if I load families and come and have a look at some different delivered ones that are coming off the shelf. So for example, if we go down and have a look at the I don't know, for argument's sakes, foundations, structural foundations, right? You can see we have pile caps. We've got rectangular footings that's already loaded into the system. All sorts of different variations of families that you may or may not want to use in this particular case, or can be opened and saved as to made into a different one. So if I load this family in here and then come back into structurals and load an isolated footing, you can see now I have one instance of a pile cap. Now again, if I look at the type, you can see there's a length, a width, there's what it calls a cutoff value, and some of these you can see if I hover over them, they have text. Others has actually an image attached to it, right? Again, this is just the way this family was to operate, right? Now, if I come in and place it at that intersection, now I have an instance of that particular family. Now, if I switch back to my 3D view, you can see those lovely, beautiful footings and my steel members along the top there. However, sometimes we want to work in slightly different ways, right? So let's go and have a look at that next. So on level 2 on grid 4, I'm going to place a steel beam. So we'll come into beams, come into a drop-down list, and you can see I've got a whole range of different beams that I may choose from. Now in this particular case, I'm going to stick with my 310 UB40, and I'm going to place a steel beam from here to here. Now, what I want to do is I want to see this tiny little section between grid A and B on grid 4 in a section view, right? So what we can do is we can come up here, and we can create a section, and we want to create the section from here to here. Now, once you place this section symbol, you've got the ability to increase or decrease the view depth and increase and decrease the actual extent of the section, because obviously you may want to place the section label only for a small distance, but you may want the system to include a little bit further of that actual section as well. And when you pick this and you right click on this, you can actually go to the view itself, and of course you can flip the section, but if you go to the view, you can see that I've now got a section view of that area because this is the extent of my view. Let's make it a 1:20 detail. Let's change the display to fine. And now we can see a whole lot more information about what was in that particular location. Now in this particular case, I may want to extend my my grid lines down because at the end of the day, I may want to see them further down than where I've got them. But you may want to place dimensions, annotations, and so on in that case. But again, being able to switch between these different views makes a big difference because it feels like you're working in 2D, but in reality, I'm actually working in that 3D space. And you can see as I start creating these views, the 3D view, level 1, level 2, the section views, they're all stored for me under my views, allowing me to switch between these as I want to, or if they're up here in the tab section, we can sit and have a look at all these components, quite simple, very much like what we would do in a 3D space in AutoCAD, right? So you get the joys and the beautiful components of working in that 2D environment that you're used to, but you've also got the ability to view things in that 3D space at the same time. So we talked a little bit about taking off the quantities of this stuff. So let's say, for example, we want to take off all these foundations and know what we've got. Let's say we're going to create a new schedule. We can filter down through the different object types, right? Come down into, say, the structural foundations. Let's give this a footing IDs, I don't know, something like that. Footing numbers, pick OK, and then we sit down and do things like maybe add the mark number, maybe get the family and type, and let's just say hypothetically the volume. Pick OK. And what you end up with this is this quantity, right? Or this schedule. Looks very much like a spreadsheet if you like. But as you can see, the data is already coming from this particular model dynamically, right? Again, we've created it. It's in the list. If I was to come back to my level 1, you'll notice that in this case, the mark numbers, this is footing 1, and I want this to be footing 2, and I want this to be footing 3, and this footing here is going to be footing 4, right? The important component here is that as I create and edit and modify this data, you can see it's modifying here at the same time. And this is important because these schedules and these views are live to the drawing, and it's these views that are moved and dragged or placed upon a drawing. So the views and schedules that you create are live to the actual model, even on the drawings. And this is a key difference between working in that BIM space versus in that 2D AutoCAD or even that 3D AutoCAD space, but you're just using solids to do one thing versus the next. Now the schedules themselves can be manipulated in many different ways, and I'm not going to claim to show you every single way or different ways of manipulating these schedules, but what I will do quickly, and for anyone who's done any sort of, how do you say, database work or Excel type stuff, you'll understand exactly what I'm talking about. So if we come in here, we can always go and add and remove different components of the actual data that is being pulled from the model, right? We can also come and look at any particular filtering, right? Now what you will notice here is that actually in reality these buttons that you see here are the same tabs that you see here. So for example, do I want to filter it by mark number, right? If it's equal to or greater than a certain value, right? How do I want to sort it? Well, in particular, I want to sort it by the mark number. What sort of formatting do I want to do? You know, with volume, you can see I've already got the cubic meters here, but maybe I want more, or instead of just 2 decimal places, maybe I want 3 decimal places, and pick OK. And once you do this, you can see the manipulation of the schedule has changed again straight away. And this is really important, right? Because the schedules, the families, they're going to be all preloaded in your template for you to reuse again and again and again per project as time moves on. Right, to try and show a little bit of the discipline stuff, what I'm going to do, I'm going to place a column. Choose a column. I'm going to place it, remember I'm on level 1. I'm going to place it by height because you can place it by depth as well. From a height perspective, I want my column to go from level 1, which I'm on, over to level 2. So I go and place the column here, and maybe place the column there. And then if you remember, we had our section view. Now you can see my column's been placed here. Now in this particular case, I'm going to place some steel connections. So again, I'm going to come into my steel discipline, if you want to call it that. Press the button next to the connections component side of things. And in the dialog box itself, I'm going to load some steel connections. So for example, if I come into a shear plate, I hit add, pick OK. I then select the 2 elements and I'm going to place a connection. Now, I don't want to use a generic connection. I want to use a shear plate. And the system then goes and creates a shear plate connection between those 2 elements, which then processes for me the actual connection itself. Now, in this particular case, if we just switch from, we'll leave it on fine, but we'll display it as a wireframe perspective, you can see that the connection itself is already there. And if I choose to edit the type of this connection, and let's say I want to duplicate this connection, I'll call this shear plate 2-hole, pick OK, and then I edit this type. I can sit down and edit parameters of this connection to suit what it is that I require. So you can see here, we have a beam with connections, which is what you see in the model. So we may say that the plate layout is on the right hand side, not the left hand side, which again, if that's the case, we should probably turn around to look at it from the other side. There we go. Now in this particular case, it's rectangular. Do we want to create the markings? What's the plate thickness? What's the plate shape? Adjusting the values for the cutbacks to 0, for example. The bolt holes, we can choose the different parameter types. So for example, if we want to do Australian connection, there we go, look, M20, 8.8 bolts, complete with nut and washer. The horizontal spacing, it's, the set out distance, 55, 35 mil edge distance, 35, at the moment this is set out from the top of the beam. So we're going to go 70, then we're going to go 35 and 70. But as I said, we want 2 holes, so we're going to go 2. And let's go 35 mil edge distance here as well. Now what we've now done, there's plenty more settings I can go mess with, just for all intents and purposes. This is now saving again that type, very much like the footing scenario. Pick OK. And now I have, and each time they change that funny blue color, that means the system's processing it in the background. I can continue working, by the way, while that's happening. And the system then manipulates the view accordingly. So if I come into here, you can see, at the moment I don't see the connection in 3D. But that's because I'm set at medium. If I go to fine, you can see the actual connection itself, right? So you can see I've got my 2-hole connection, and you can quickly manipulate by type what it is that we want. And of course we can switch back to our shaded mode, for example, right, to give us that same sort of perspective. You can see from a discipline perspective exactly what it's given you. All right, so let's say I want to place a slab. So we've talked about footings, columns, beams. Again, I want to place some sort of floor, right? So first of all, you have to accept the type that you've got. So let's just say hypothetically we're happy with the 300 mil slab footing. Now you can do one of a few different things. I can sit and draw the boundary, okay, and then lock this in place, say here and here. And let's say I want to change the shape here somehow. I can then come in and draw in the actual shape. And the system will then allow me to come and do all sorts of things like trim and extend a profile. Oops. So there I've actually gone the wrong way around. Right. So in essence what we want to do is we want to go to here, other way around, trim. There we go. So what I've now done, when I hit OK, that now creates for me my concrete slab. Again, back in 3D, you can see my particular concrete slab. Obviously, I'm missing some components when it comes to the columns that I may need. But you can see how that concrete slab has the same sort of parameters, but it's again a different particular type, right? And our slab can be made up of all sorts of different things. So the slab can have multiple layers. Maybe you've got a screed layer. Maybe if you think of this slab on ground, you've got a 1 mil membrane to stop the water from seeping through. Maybe you've got compacted soil below it. The slab can consist of multiple layers as part of that edge, right? And then you get to see how this actually manipulates and moves forward. And again, if I was to place a section, so if I went back to level 2, remembering that at level 1, I've got footings along grid 2. So if I was to place a section through grid 2, I would create a section, pick the direction. Now at the moment you can see the section's going all the way through for the moment. Let's leave it like that. If I go to the view of the section, you can see there's quite a bit of information here. So if I was to drag this down, Now I get to see the components on the near side, the far side, and then as I manipulate the depth of that section, it'll change. So for example, go back and have a look. Let's say we place on level 1. Let's go back to level 1, place a column, let's say here. If you go back to the section, we can see our section, right? So if we change it to fine, then if we were to refer back to where I created the section on level 2, if I grab this and pull this back and pull it back to here, you'll notice this column now sits outside of it. Go back to section 2, again you'll notice it's gone. Again, continuing with that theme that really this is just a bunch of 2D views which are live to that 3D, right? So what I see here is the actual slab itself. If I change the type of slab here, it changes in all my views. Just like as if I was to change it here, 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 or here, it doesn't matter. It's dynamic. All right. So now we've got all our views, we've got our design. How do we actually document this stuff, right? And it's quite interesting when we start looking at this. Again, as I said, all the views are self-contained in this project browser. Well, our drawings are much the same way. If I right-click and say I want to create a new sheet, there is a prototype or a drawing sheet family attached to this particular model. Click OK. You can see there is my actual view itself. Now let's say, for example, we want to take level 1 and stick it on that drawing, right? So first of all, we can choose to delete, we can rename, right? So let's say I want this to be S1, right? And let's call this level 1 plan, right? Or level 1, whatever it is that we want. When we're on this sheet, all we need to do is come and grab level 1 and drag and drop it into our actual sheet. And that's how we get our view on our page. And we can drag as many of these views on our page that we like. The beauty of this is if I was to copy this, right, and then more and more and more, right? So obviously this is going to be a new mark, so this is going to be footing number 5. Right, pick OK, save, go back to our sheet, and you should see there it is. There's our sheet, been updated just like it was in the view, because this is just a view directly from our model. You know, we've got all sorts of things like annotation tools, dimensioning tools. You can see they're all there, everything you would expect, and you can actually do most of it in this particular case. So, we can sit and annotate, all the different things in one go automatically, or we can place single tags or individual tags per object. So for example, as I go near an object, this is the particular definition of that tag. We can place them next to all these individual items. And again, this is controlled by the definition or the family definition of that particular tag. We can edit this tag and do what you like. The beauty is that everything that's related to this view is related back to the control of the scale. So if I switch to 1:50, you can see everything gets smaller. 1:1000, everything gets bigger. So you can sort of see this is exactly what the drawing is going to look like. Even though when we come here, you can see the drawing as well. We don't need to come to this drawing in this particular location. And you can see if I was to create a new sheet, click OK, there's drawing 2, and then maybe we come and drag those particular sections that we had, that we drew before, onto here as well, and you can see we get the sections come through. Now, let's make a third drawing, and let's drag level 2 onto there. Now, the thing that you're going to notice straight away, all right, that's maybe a little bit big. Let's go back to level 2, and let's make that 1:100, just because make things simple. And drag that in. Right, so if I place that, and have a look, you can see the different types of views that we've got on this page. Go back to section 2, go back to section 1, you can see all those particular annotations. Quite interesting in how it all works. The other thing you'll see is that the sections themselves, they've got section numbers, everything's sort of nice and neatly shown, and because I've shown it in particular ways that make sense, you sort of get the display that you're looking for. Last but not least, we've got our schedule. This too, just like anything else, can be dragged and dropped into our particular drawing, right? And again, this is dynamic in that this list or this object suits the layout or suits the text style that's been set up inside this drawing. It pulls the data from the actual schedule, and the schedule pulls the data from the model. So as you can see, when I added number 5 to the list, it increased in size. Same thing goes here. If I was to copy this again down and look at that and make that mark number 6, right? We've now updated our view. So again, you would think in my level 1 plan, I've got my extra footing. On my third drawing, nothing changes. On here, because my footings have changed, I've now got an extra pier or extra footing with a tag number according to what I was looking for. Awesome. Hopefully that gives everyone a rough explanation of how this works. Okay, last but not least, a rather simple but nice way to put it all together example of a real world scenario. This was a model done by a colleague of mine. If you have a look here, it's a house design. There's pools in here. There's chairs, there's tables, there's trees, there's the garage. And this is just a little simple house design. You can see in the object browser, there's a whole lot more views than what there was in the previous samples that I showed you. Everything from different elevations, showing different scenarios of the actual house itself. So seeing that front end view to isolated 3D views showing the drainage, for example, of the plumbing in a house. So you can see the toilet is connected to this pipe here, which is connected back to this toilet, down to the lower end, all very in nice detail. So you can see here when I click on this, it's a PVC elbow. It's got a 50mm radius. There's a whole lot of information. It's 110 diameter. This is obviously a PVC pipe that's of the same type. We've got a T here. We've got a lovely, beautiful toilet here, that's been created. And again, you can see the level of detail is really up to the individual to determine. And likewise goes for the drawings. You can see the drawings themselves, as you go through them, show you a whole lot of information, everything from shadow diagrams to, landscaping to the ground floor itself. So you can see here, in this particular case, you've got the ground floor, the dimensions for the layout, the walls, the cars. Everything's in here, but it's still all a nice, intelligent bunch of objects with the views themselves that come from up in this particular area themselves. So you can see how there's quite a lot of detail here. And in the cases where we've actually dragged the sections onto a drawing, the section numbers automatically correlate to the actual drawing themselves. So you can see section 1 is on A300. If we go to sections A1300, you can see section 1 is here. If this drawing was to change number, this section number would change, and so on. The intelligence or the connection between all the objects is a whole lot more different, giving you more control over your design because there's less things you need to worry about. You don't need to worry that you need to update elevation number 55 with the change that you made in the plan view, and so on and so forth. You don't have to worry, did I change the number of that section? Have I already used section number 5? All those little things that you worry from a drafting perspective, you can somewhat ignore and concentrate more on the design component of what it is that you're trying to do. So just recapping what we looked at today, remembering it's a process, it's not a thing. We don't model 2D elements or dumb 3D solids. Everything is intelligent. It's accurately placed. There's a relationship between the objects, and there's a humongous amount of data that is accessible inside of all these objects. The views themselves, the representation of all the objects can be changed, giving us more and more control over what we see and how we use that information. We support multidiscipline environments, making it easy to place parametric objects that change dynamically, making it easy to do the design but also change the design, giving us more time to concentrate on the design itself. So hopefully this has been enough to get you some interest in Revit today. For those of you who are interested, please contact us for some more information. For now, thank you very much for your time. Hope you enjoyed. Bye-bye.